Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface and look at chapter 4 of Oracle's online documentation. So in chapter 4, let's start with looking at accessing fields of objects, and then let me also bring up the fields. So accessing fields in C++. So JField ID. So fields are just in the header of a Java class. Basically, fields are basically have some IDs, have some offset, because again these are pointers. So get field ID, we have to pass a J class because we have to tell JVM which class we want to talk about, right? So J class has all the meta information of the class, so JVM knows which class we're talking about. And then const char pointer, a raw string literal or a C style string, right? Const char pointer, that's the name of the field, and then the type, right? Const char pointer signature. Signature here is the type. So we said that both fields have signatures and both methods have signatures. The reason for methods for us to have to specify the signature in addition to name is that Java allows method overloading. So different methods might have the same name if they are overloading each other. So the name is not enough for a method to uniquely identify it. Same with fields. So fields might have the same name but different types or different signature, right? Signature for field means its type. But fields can have the same name if they have different types. So the name of a field is not enough to uniquely identify it. We have to also specify the type, right? So, and again, the process is very similar to Java Reflection API. We get the J class object, which has the meta information. It's equivalent to the J class. And then we get the field object, which is basically this JField ID that we get based on the name of the field, right? Get declared field name. And then this basically in Java we don't need to specify the signature. The reason is that the field class or the field object here has a get method, but then it returns a object, right? So field get on this particular person object, it returns it returns an object, right? But there are some specialized methods for primitives. So get int, get double. So when we use get, it means we want the field is an object. When we use, for example, get int or get double, it means the field is actually an int. So it has a specialized method, so we don't need to specify the signature in this get declared field. But in C++, in order to get the JField ID, we have to also specify the type of the field or its signature, right? So we get the J class first, and we can use a find class and search for that class on the class path, or we can use get object class if we have a reference, J object reference to an instance of that class, right? So we use find class to find the class on the class path, and then we have to get the JField ID. So JField ID, get field ID. If it's a static field, we use get a static field ID, right? And then once we get the field ID of a field or a static field, again we specify the name of the field and also its type. If it's an object, the type starts with LL and ends with semicolon. This is the standard signature of Java objects inside the JVM. And this gives us a JField ID. Now we have to retrieve the actual value of the field, right? So if it's a primitive type, again, it has a specialized functions for primitive types. Get the primitive type field, and we pass in the J object, the object that we want to retrieve the value of the field, and then the JField ID that uniquely identifies which field of this object we're talking about, all right? So if the field is a Java object, it's not a primitive, we use get object field. So this type, which is a primitive type, or this object, these are basically the type of the field or the signature of the field, whether it's a primitive or it's a Java object, right? So get object field, it means get a field that is a Java object. Get primitive or whatever primitive type here field, it means get a field that the type is like a primitive type, right? So returns the field ID for an instance non-static field of a class. For a static field, we use get a static field ID. Get a static field ID. And for static fields are class level fields, right? Class level variables. They're not associated with an instance. They're not associated with a J object. They're associated with a J class, right? So for field ID, we always pass the J class because it's a property of the class itself. But then for the field, if it's a static field, we have to pass the J class instead of J object. So the field is specified by its name and signature. The get type field, right? Get type field, and then set type field families of accessor functions use field IDs to retrieve field objects. So get field ID, get type field retrieves the field, the value of the field, and set type field sets the value of the field, and we have them in the setting object. So get a static field ID or get field ID, and then set type field or set object field. So if the field is an object, then we say set object field. If the field is a primitive, we say set type field, and the type can be any primitive, set double field, set int field, etc. Alright, so get field ID causes an uninitialized class to be initialized. Get field ID cannot be used to obtain the length field of an array. Use get array length instead. And again, dealing with arrays, we know that arrays are objects in Java. A primitive array has a length, or even an object array has a length. But it says that you cannot retrieve that using the get field ID. Just use the specialized functions inside the JNI that are designed for arrays, and one of them is get array length, and we have seen this in many times. So get array length, let's say array, working with primitive arrays, and we saw that for objects, when we work with arrays, we can get the length of the array using get array length. And linkage, this get field ID is index 94. Again, all these functions are function pointers inside the JNI environment interface. So index 94, the parameters for C++, we don't need this the first parameter, we don't need to pass the environment again. The class is a Java class object, J class. Name the field name in a 0 terminated modified UTF-8 string, which is basically C style string, const char pointer. The signature of the field, it's Java type that is represented inside the JVM. The field signature in a C style string. Returns a field ID or null if the operation fails. Throws no such field error if the specified field cannot be found. Exception in initializer error if the class initializer fails due to an exception. Out of memory error if the system runs out of memory. Get type field routine. So again, let's go back to fields. Get type field, it means get a field of this object with this field ID that is a primitive type, right? Get type field routines, native type, which is primitive type, get type field, it gets a J object, right? And then the J field ID. This family of accessor routines returns the value of an instance, non-static field of an object. The field to access is specified by a field ID obtained by calling get field ID. The following table describes the get type field routine name and result type. You should replace type in get type field with the Java type of the field, and these are all primitives, or use one of the actual routine names from the table and replace native type with the corresponding native type for that routine. So get type field family of accessor functions. Get object field, it returns a J object, right? We said that if the field is a Java object, it's not a Java primitive, we should use get object field. The rest is just primitive types. Get boolean field, it returns a J boolean, right? Get byte field, it returns a J byte. Get char field, it returns a J char. Get short field, it returns a J short. Get int field, it returns a J int. Get line field, it returns a J line. Get float field, it returns a J float. Get double field, it returns a J double. Now the difference here is that all these primitive types, J boolean, J byte, all the way to J double, they directly maps to C++ native types, right? These are all type defs, so we can immediately use them. However, get object field, it returns a pointer, JObject, which is a pointer. So then we have a reference to an object, so we have to use other JNI functions to be able to work with this object, right? For example, if the field is a string, we get a JObject, we can typecast it to a JString. So here, get object field, because the name is a string, a Java object, person, and then field ID. It gives me a JObject, and I cast it to a JString, because I already know that this type is actually a Java string. And then this is still a reference, a pointer JString. I have to use another function inside the JVM, to get the actual characters or the CS style string of that JString, which is get a string UTF-chars, right? And now I have a CS style string, I can work with it. And remember, when you get a CS style string, whenever you get a raw pointer from one of the functions of the JNI, we have to also call the release function. All right, linkage, all these functions are get type field. They start from 95 index, 96, 7, 8, 9, 100, 103. And then they take a JObject, because we're talking about the instance fields of objects, not static fields. A Java object must not be null, and a field ID, a valid field ID. And they return the content of the field. Set type field, and again, these are for setting the values of the fields in C++, right? Set type field, and the type can be a primitive or an object, right? Set object field. This family of accessor routines, and again, they get a reference to a JObject and then a JField ID, so that JVM knows which field we want to set its value, and also the value that we want to put in, so native type value. And this, if we are talking about primitive types, this is obvious that it's a C++ primitive types. If it's object, then we have to use the correct value. For example, if it's a string, we have to use a JString reference, right? Get field ID, it's a name, L Java/lang string semicolon, and then set object field, name ID, and name. This name is a JString, right? All right, and then if I want to set this integer value, get field ID, and then set int field, and the JObject, JField ID, and then a JInt, and we already know that JInt maps to int, which is a primitive C++ type. So working with primitives is easier than working with object types, right? JObject types. If I didn't have a JString here and I wanted to use a CS style string or raw string or a string literal in C++, I have to ask JVM to first create a Java string from a CS style string, raw string, and it gives me back a JString reference, and then I can put that JString here, right? So set object field, you have to be very careful that if it's a Java object, you have to put a JObject or a JString or whatever, right? You cannot put a primitive type. The strings, a CS style string or a string literal, you cannot put it here. JNI functions don't work with that. The following table describes the set type field, routine name, and the value type. You should replace type in set type field with the Java type of the field, or use one of the actual routine names from the table and replace native type with the corresponding native type. Again, set object field, it means set the value of this field, which is a Java object, and then it takes a JObject. Set boolean field, it takes a JBoolean. Set byte field, JByte, all the way to set double field, JDouble. And the primitive types directly map to the primitive types of the C++, which is much easier to work with, right? Linkage indices in the JNI environment interface function table. It starts from 104 to 112, right? So I can offset my JNI environment pointer, add let's say 112 to this pointer, and then call it, right? Function pointers are callable. All of these functions inside the JNI environment, these are all function pointers, right? Which is a 8-byte integer, right? A long integer. 64 bits addresses on a 64-bit platform are 64-bit. Set object field. Okay, they take a J object, a J field ID, and a value that can be any native type, either a J object or a J primitive types. Calling instance methods. So calling methods, and again, it's very similar to JNI similar to Java reflection. We get the class of an instance object and then get declared method and get name, and then we invoke it. In C++, we say call it. In Java reflection, the method is invoke. We get a method handler and then we invoke it on a person and it returns an object, and then we can cast it to whatever we want and then do whatever we want to do with it. So in C++, obviously the first thing is J class. We have to have reference J class meta information of that class so that JVM knows which class we're talking about. And then we have to get the method ID. We have to get the method ID so that JVM knows which method we want to talk about, right? And after that, in order to call it, we have to also give JVM the parameters that method takes. And because JVM allows method overloading, the name of the method is not enough to uniquely identify it. We have to also provide its signature. And the signature of a method is the signature of its parameters in round brackets and then the signature of the return type. All right. So J method ID, get method ID. It takes the J class, a const pointer name. This is a string literal, and const pointer signature of the method. Returns the method ID for an instance, non-static method. If it's static, then we say get a static method ID. And works both on classes and interfaces. And we have seen when we talked about the interfaces, calling interface methods, because we said that from Java 8 interfaces can also have static methods, right? But interfaces are by default have abstract methods. From Java 8, they can also have default methods, which has an implementation. So either abstract, default, or static. And we said that get method ID works both for abstract and default method. It doesn't matter if it's a default or not, right? The method may be defined in one of the class's superclasses, right? And inherited by the class. That's still fine. So for abstract, for inherited or overridden methods, that's work fine. For regular methods, works fine. The method is determined by its name and signature. Get method ID causes an uninitialized class to be initialized. To obtain the method ID of a constructor, use init in diamond brackets. And this goes back to our talk about initializing a Java object, and we said that we have to call the constructor, and constructor is just a special method. The name is init in diamond brackets, and its return type is always void, right, for constructor. So supply init as the method name and void as the return type, right, in order to get the method ID of the constructor, which is a special method. Linkage index 33 parameters. It takes a J class and takes a C style string for the name of the method and a C style string for the signature, and returns a method ID or null if the specified method cannot be found. Throws no such method error if the specified method cannot be found. Exception in initializer error if the class initializer fails due to an exception. Out of memory error if the system runs out of memory. And then we get the method ID, and in order to call it, we say call type method. If it's primitive, if it's an object, basically here this type refers to the return type of the method, right? So it takes a J object, J method ID, and a vararg, right? And we said that there are some methods in functions JNI that end VA and V. A means it takes an array of J value. V means it takes a VA list object or a struct, right? I personally normally use just the ... version, which is the original version. And then the call methods are specified by the type of the return value. So if the return value is a primitive, we say call int method, call double method. If the return value of the method is an object type, we say call object method. So it returns the native type. Call type method takes a J object, J method ID, and dot dot dot. The one that ends with A, it takes an array of J values. Const J value pointer, which means it's an array of J values. The one that ends with V, it means it takes a VA list, a struct, which is basically a list of J values, right? Methods from these three families of operations are used to call a Java instance method from a native method. They only differ in their mechanism for passing parameters to the methods that they call. So these are basically under the hood. They're basically doing the same thing. The only difference is that how we pass the parameters to these functions. These families of operations invoke an instance or non-static method on a Java object according to the specified method ID. The method ID argument must be obtained by calling getMethodID. When these functions are used to call private methods and constructors, the method ID must be derived from the real class of object, not from one of its superclasses. For private methods or constructors, we have to use the actual class, right? Not one of its superclasses. It's always best to use the real class. Call method routines. Again, when we get the method ID, then we can call the method. Programmers place all arguments that are to be passed to the method immediately followed by the method ID arguments. Call type method routine accepts these arguments and passes them to the Java method that the programmer wishes to invoke. The one that ends with A, programmers place all arguments to the method in an args array of J values that immediately follows the method ID argument. The call type method A routine accepts the arguments in this way and in turn passes them to the Java method that the programmer wishes to invoke. The one that ends with V, programmers place all arguments to the method in an args argument of type VA list, which is basically a struct, a list of J values that immediately follows the method ID argument. The call type method V routine accepts the arguments and in turn passes them to the Java method that programmer wishes to invoke. Call void method A, call void method V. The return type is void, and again, these call functions are specified by the return type of the method, right? Call object method A, call object method V. The return type is a J object. Call boolean method. The return type is a J boolean. And for the rest of the primitive types, call int method, call long method, call float method, call double method. They return J int, J long, J float, J double. And indexing, the void ones are 61, 63, 62, and then the rest are the indices. So parameters, they take a J object and a J method ID and then some other arguments that are mapped to the arguments of the method in Java. Additional parameter for the call type method is arguments to the Java method. The one that ends with A takes a array of J value, and then the one that ends with V, it just takes a VA list type. And these functions return the result of calling the Java method. That's the return type of the method. And throws exceptions raised during the execution of the Java method. Any exception that is raised during the execution of the Java method can be thrown by these functions. Call non-virtual. Okay, so non-virtual. Non-virtuals are basically, we said that all calls or methods in Java are by default virtual methods, which might have some overheads at runtime, especially if we have a method that has never been overridden. We don't really need to call it virtually. We can use the call non-virtual method, right? Call non-virtual type method routines, call non-virtual type A, and call non-virtual type V, right? Call non-virtual type method, it takes a J object, J class, J method ID. So for call, the ones that don't have this non-virtual, they take a J object and then J method ID. But for non-virtual, we have to specifically mention which class we want to call it, right? So that's why we also have to provide the J class. And then these families of operations invoke an instance non-static method on a Java object according to the specified class and method ID, right? So when we say call non-virtual with this J class, JVM just goes to this J class and invokes this method, right, on this object. So it doesn't matter what object we're talking about, whether or not this object is actually this of type of this class or a subtype, doesn't matter. JVM just goes to this J class and invokes whatever method is inside defined exactly in this J class, right? The method or the argument must be obtained by calling get method ID on the class, right? The call non-virtual type method families of routines and call type method families of routines are different. Call type method routines invoke the method based on the class of the object, while call non-virtual type method routines invoke the method based on the class designated by the class parameter. So basically, call type method, these look at the J object and figure out what the J class is, and then they look at the class type of the object. But here, the non-virtual ones, they don't look at the type of the J object. They look at the basically the J class that we explicitly provide, and then the method, and then if the method requires some instance parameters or some fields, then it takes it from this object, right? Call non-virtual type method routines invoke the method based on the class designated by the class parameter from which the method ID is obtained. The method ID must be obtained from the real class of the object or from one of its superclasses. Call non-virtual type method routines, programmers, again, this doesn't end with anything, so you pass a ... or as a variable arguments. The one that ends with A, you pass an array of J values, and the one that ends with V, you pass a VA list struct, right? And again, non-virtual void method, the return type is void. Again, all the call functions, they are specified by the return type of the method. Call non-virtual object method, it means call a method, its return type is object. So in C++, we get a J object and we're calling it non-virtually. Linkage, these are the indices of these functions, right? And the parameters, they get a J class and a J object and J method ID. And then the arguments to the Java method, we have to pass them either as ... a variable list, or an array of J values, or a VA list structure. And these methods, these functions return the result of calling the Java method, and they can throw any exceptions that can be raised during the execution of the method, right? All right, so I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.